Okay, everyone. So my name is Stephen Prasetya, and today we're going to be conducting a test on Smart PLS and the subject of statistics. And here we're going to test a few. Uh, we're going to run a few tests. So first step is we go to Excel, Microsoft Excel, and find our data here from the survey. Okay, so here we have a lot of variables, dependent variables, and also the mediating variable. So after we convert this XLSX data format into CSV by going to File, Save As, and going to whatever you guys want, like documents or this PC to downloads, and you can go and save it as CSV right here, comma deleted UTF minus X. But since I've already done that, after you saved it into a CSV format data, you go to Smart PLS and you click New Project and you type here Smart PLS ALP or any name you want for your project. Click OK and double click to enter your data. Input the data of the CSV file you've transformed into here and press Open. OK, and then you have this data. Now, Uh, since you have been provided with the required data to conduct your test, first open your canvas on this button right here. Press Smart PLS app, ALP. So first we're going to use these indicators. Alright, so the independent variables I'm going to use here is new, which stands for neuroticism, and CO here as the second independent variable. For the mediating variable, we're going to use AI usage. Put it right there. And the last is the dependent. We're going to use OB. All right here. And don't forget to connect them. First, I'm going to connect this into the mediating variable. Do the same for the second independent variable. And then the mediating to the dependent, which you can see is turning blue because we can run a test with it. But do not forget to also connect it in a direct method. So after you've connected all of this, you can run the test right now. Now, the first method we're going to use is the PLS algorithm. So for PLS algorithm, the required maximum iterations is minimum 300, which is already enough for calculation. We run the test and we see the outer loadings. As you can see here, all of them, almost all of them is green, which is valid for test, except for OB4. Now, what you have to do is go back to the canvas, delete OB4, which is the invalid data, run the test again, press PLS algorithm, start the calculation, and then, as you can see in the outer loadings, all of them have turned green. So that's the first step done. So, second step is go back to the canvas, calculate, and here we're going to test its significance. From bootstrapping, the subsamples are 500, but if you want to go for more, is enough, it's okay too, but it won't be necessary, since it will take a longer time for the computer to calculate the results. Right, so moving on to the next part, which is the bootstrapping. So for bootstrapping, as you can see here in the outer loadings, the p-value of all variables that we've inputted are 0.000, which means that they are less from 0.05, which proves that they are significant. Next part is we go back to the PLS algorithm and see that in the part of construct reliability and validity. For row A, the number that is being represented by row A is in the middle of current batch alpha and composite reliability. And it means that if they exceed 0.7, and it means that they are valid and reliable. And Since we have all of those numbers green and above 0.7, they are all valid and reliable. And then the next part is the AVE, or average variance extracted. So as you can see here, the average variance extracted is more than 0.05, which means that they are green, represented by the green color, and they are uh, reliable. And the AVE, or average variance extracted, represents whether the indicators used to measure the variable really have the high correlation with this variable. And as I said, if it's more than 0.5, then the convergence validity prerequisite is fulfilled. And moving on to the convergent validity, if the convergent validity is used to show whether the indicator really represents the variable, while discriminant validity is used to know whether the indicator of a variable is different from indicator of other variables. Now, moving on to the discriminant validity, there are three methods of doing it: the Fornal-Lacker criteria and cross-loadings, and then the last or suggested one is the heteromonotrates uh, method. So, as you can see here, the numbers representing the HTMT is not exceeding 0.9, which means that they're good and they fulfill the criteria of the discriminant validity. And the prerequisite states that if the value of the HTMT does not exceed 0.9, then it is good. Or in other words, the indicators representing the construct is different with indicators representing other constructs or variables. So continuing where we left off, then our model is the reflective model. So we do not need to conduct outer model collinearity test anymore, since our model is a reflective model. Now moving on to the inner model, we take a look at the collinearity statistics, or VIF. As you can see here, the numbers of all the VIF is green and it's less than 5, which means that there is no multicollinearity issues. Next, we will test the direct and indirect effects in the bootstrapping section. Now, to take a look at the mean STDF t-values section. So, uh, in here, we can see that the uh, path coefficients uh, shows that the neuroticism to the overconfident bias is red, while the others is green, which we will interpret in the next section. Now, it is for us to interpret the meanings of the diagram. For AI usage between neuroticism and overconfident bias, it is a fully mediation because the direct effect is not significant and the indirect effect is significant, while AI usage only partially mediates between conscientiousness and overconfident bias because the direct effect is significant while the indirect effect is also significant. So now we're moving on to the R square. R square represents the proportion of dependent variable which can be explained by the independent variables. So now we can see that 23.5% of AI usage is explained by conscientiousness and neuroticism, while 26.4% of overconfidence bias is explained by neuroticism, AI usage, and conscientiousness. And using primary data, the ideal value of R square is more than 0.5. And moving on to the F square, the S square, which represents the effect size, and it's about the relative effect of independent variables to dependent variables. So basically, it's to find out the change in the R square if an independent variable is removed. So as you can see here, conscientiousness towards AI usage is a medium effect. Neuroticism to AI usage is medium effect. AI usage to overconfident bias is small effect. Conscientiousness to overconfidence bias is small effect, and also neuroticism to overconfidence bias is also small effect. Now we move on to the last part of the Smart PLS program. Now we use blindfolding, and start calculation. And as we can see here, that the AI usage has smaller relevance, and overconfidence bias also has smaller relevance. That is it for the Smart PLS project. I'll see you guys later. Bye bye.